Hey, what's going on, guys? Let's try this problem right here. Here we have a spaceship that is traveling with very high velocity related to the stationary frames of reference, and in front of the spaceship there's a flashing light, right? And that is flashing with this frequency, that is 100 hertz. And by the time this spaceship traveled this far, the light has traveled this far, right? And the question is asking what's going to be the frequency observed by the person on the earth. Now let's see how we can find it. And if you notice, if the light has traveled this far, this spaceship has traveled this far, and light has traveled this far, therefore the lambda, that is wavelength, is going to be observed by the person on the earth is going to be this distance only, right? This distance. So this distance lambda observed can be calculated by the distance of the light traveled minus the distance of the spaceship traveled. That is this equation, right? Ct is the light traveled, speed of light times the period of the light, and speed of this spaceship times period of this light right here, right? Now, so this is the equation for lambda observed. Now let's see how we can use this one to calculate this f observed. Now the equation we are going to use is C is equal to f observed times lambda observed, similar to v is equal to f lambda, right? Here c is speed of light and f observed is what we are trying to find, and lambda observed is going to be this distance. Now if you rearrange this equation, that's going to be f observed is going to be equivalent to c over lambda observed. Now we can replace this lambda observed with this equation, right? So c over c minus u times the period. Now we have c, the speed of light, and this one. And here what we can do is we can use this time dilation equation. So we know the time dilation equation is this one, and that is equal to gamma times t naught. So we can use the same equation for period. Period is going to be t is equal to gamma t naught, and gamma is 1 over this value. So we can also write this one as 1 over square root of 1 minus v square over c square times t naught. So this is going to be just t naught over this value, right? Now this is our relations for period and this one. So t naught is the period observed by the person on the spaceship, right? And we know that frequency observed by the person on the spaceship is 100 hertz. So we can calculate the period observed by the person on the spaceship, that is 1 over 100 second, right? Now we have this one. Now let's see how we can use this to here. So here, since we are dealing with period observed by the person on the earth, so this is the one we are applying right here, right? Now we can also replace this t with this value, t naught over this one, because we don't have the t available, right? So we can replace this one, and this is going to be c over c minus u, and t is going to be flip of this one because it's in the bottom. So the equation we are going to put right here is going to be square root of 1 minus v square over c square over t naught, right? T naught. Now let's rearrange this one and get a better equation. So here what we can do is we can take the c square common. So if I take the c square common, this is going to be c square minus v square over c minus u times t naught. Now I can take this c square in the bottom outside, so this is going to be c over c square root of c square minus v square. I can write this one as c minus u times c plus u, right? And in the bottom we have c minus u. I can write this one as square root of c square c minus u square, right? Now if you notice, we can cancel this one, this square and this c minus u. So we are left with c plus u over c minus u, and this c cancels, and we end up with this one, square root of, and also we have a t naught right here outside. So this is going to be c plus u over square root of c minus u times t naught, right? Actually t naught is in the bottom, t naught. Now we have brought the basic equation. Now we can go ahead and plug the values, right? So here now we can plug the values. Let's go ahead and do that. So here we are going to have c plus u, and we know the speed, u is speed of this moving frames of reference, that is 0.8 c. That's speed of this spaceship, right? So this is going to be c plus 0.8 c over, let's continue with this one right here because we don't have space. So let's continue this one. So here we're going to put square root of c plus u, c plus actually 0.8 c, right? 0.8 c. In the denominator we are going to have c minus 0.8 c, and then we have to in the denominator we have to multiply this one by t naught, or we can multiply by f naught in the top, because we know that f naught is going to be 1 over t naught, right? So instead of putting t naught in the denominator, we can multiply by 100 f naught, and let's simplify. So if you simplify this one, you will end up with 1.8 over square root of 1.8 over square root of 0.2, right, times f naught. So f naught is 100, we already know that one right here. So we can multiply that one, and 1.8 over 0.2, that's going to give us 9, and square root of 9 is going to be 3, right? So this is going to be 3 times 100, and that's going to be equivalent to 300 hertz. So this is going to be the frequency observed by the person on the earth. So frequency observed by the person on the earth is going to be 300 hertz, and that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.